A very good morning to you. It's been quite some time. I couldn't do any kind of lectures. I was a bit unwell, and it took me around 1 week to recover. And hopefully, I'll be better from now on. I'm feeling much better. And thank you for understanding. Today, I'm going to continue with what we have left from last time's class. We finished Unit 1, and now let us get back to Unit 2, that's on water resources. To cut short the video clip and to let you download the smaller size videos, I'll be doing around 5 small clips on Unit 2. Please look all the 5 to 6 small video clips. And again, I will not do any kind of word of the day or greeting slides and reflection. We'll be continuing with that one when we start our normal session back. So let's straight away begin with Unit 2. So Unit 2 is divided into two lectures. First lecture is on water issues related to supply and demand, and the second is on basically a combination of surface water volume, aquifer performances, and groundwater and wetlands. So I really hope towards the end of the lesson you'll be knowing what are different kinds of water resources, and specifically surface water, groundwater, and wetland characteristics. So today's lesson will be mainly on the first part of the Unit 2, that's on identifying water issues specifically related to supply and demand. So just to give you an overview of the issues that we have in around the world, lots of countries are facing the issue of water shortage, and some of the countries are facing a severe issue in terms of water shortage. And the good thing is that lots of stakeholders, lots of countries are coming together to solve this issue together. However, there are lots of challenges that's left to be solved. And again, lots of researchers, lots of experts have come together with lots of concepts and empirical ways to solve this problem, but none of these are seen as one of the best ways in order to solve the water issue throughout the world. So solving water issues throughout the world, specifically related to supply and demand, is basically country specific and community specific. So let us delve into what are exactly the issues that's being related to the supply of water and the water demand. Let us look at the issues related to supply of water resources. When I am talking about supply of water resources, I'm basically talking about how resources are established in the planet, on the planet, and how can we use these water resources in order for us to meet our demand. And supply is basically supplying of these water resources from different kinds of sources. The earth looks blue from the outer space, and from the earlier classes we knew that it's mainly because 70% of the earth is being covered by water. And though we have 70% of water, we saw that only around 2.5% of the whole 70% of the planet is fresh water. And again, out of that 2.5, very little amount of water is being left for us to use in a sustainable way. That's in the form of lakes, in the form of rivers, streams, and all. So most of the water is mostly inaccessible, though they are fresh water. If we just compare the fresh water available on the planet, if you look at the big blue dot, that's the actual fresh water that's being available in the uh, in the whole globe. And from that, the small or the tiniest drop that you see is actually the water that is available for us to use sustainably. That means that's the water that's being circulated or distributed around the globe as in the form of rivers, streams, lakes, and other reservoirs. Again, another way to look at the planet is that if this is the planet, and the small drop is what we are left with in the form of rivers and streams. So basically, I want to tell that the kind of fresh water that we have to use sustainably is around 0.01% of the total water. This is one slide that we were talking time and again in our previous classes. Though we have around 70% of the planet covered with water, around looking at the 70%, if we take that 70% into 100 of the total water, around 97.5 is being taken up by oceans, and 2.5 is just fresh water. That's a big blue dot that we saw on the planet. And again, out of that 2.5, which if you take as 100% again, ice caps and glaciers, they amount to again around 70%, and 30% is being taken up by groundwater, and rest remaining around 0.1% or like 0.2% is being left for us to be used actually. And those are again in the form of ice and snow. That's 0.97 in the form of ice and snow, 2.6% in the form of lakes and all, and some of are in atmospheric water, just in the atmosphere in the form of vapor, clouds. Some are in marshes, and some are in biological water, meaning inside the plants and animals. So the amount of water that's being left for us to consume is around 0.006%. That's for rivers, and around 0.26 that's for lakes, and rest are almost inaccessible. So that's the nature of the supply of freshwater resources to us, and that itself is an issue for us. Again, another analogy can be if we have a bucket full of water, and the amount of water that can be used for the sustainable daily use by human population is around the spoon. So again, like yes, the spoon accounts for again 0.01%. That can be used by human population. So again, I'm stressing that the limited amount of water that we have on the earth itself is a constraint, itself is an issue towards the supply of water. The question is that if 0.01% of water was left for us to use sustainably from long time back, the main question that I want to ask you is that back then we had dinosaurs, lots of huge trees, plants, lots of huge animals who had to consume lots of water. And again, the question is that do we have less water today than a million years ago? Meaning today we do not have such giant animals living, giant plants, and giant creatures like dinosaurs living anymore. So are we consuming less, or is there only less supply of water as compared to previous? So that's the question that you need to think for around like 2 to 3 minutes, and the answer is that back then, during those millions of years era and the time right now, we have actually same amount of water. It's not high or it's not low, it's just the same amount of water. The same amount of water is being circulated by what's known as hydrological cycle in nature. So it's not getting out to the space, it's not getting deep down inside the core or the mantle of the earth. So it's the same amount of water that's being left on the planet. So it's basically same. So again, yes, so that itself is an issue. But the main issue is that Though we have same amount of water, it should be sufficient for us. But the main constraining factor that is related to the supply of water is that population is increasing, and with increasing population, our daily needs of water, not only for drinking but other domestic purposes, industrial purposes, uh, power generation purposes, are again increasing, where water is one of the main components to produce all these things. So in 1940s, water scientists, the water experts, they found that one bucket of water, or like the per capita water, was enough for one person in 1940s. So meaning the population was not that high and rampant, but in around 1945, the population doubled itself. And when population doubled itself, again with developmental activities going on, the requirement of water again increased. So one person now actually uses around twice the size, or twice the amount of water that's being used in previous years, like 1940s. So again, increased amount of water. And again, the projected data for 2050 is that the population will increase. Again, the water usage or the water demand is going to increase. So the issue related with the water supply is that it's never going to increase in future, but the population is going to increase, and the matching of supply and demand is not going to be there. So this is one of the main issues that we face in terms of supply side of water. And the last slide on supply issues on water. In around 1995, if you look at the amount of water that's being withdrawn from the surface, or that's being withdrawn from the groundwater or from other resources, where around only few countries were having around withdrawal rate of more than 40%. So these dark oranges are basically those countries which had water withdrawal rates more than 40% of what water is in their country. So if they have the potential to have around let's say 40 cubic kilometer of volume of water, then 40% of those 40 cubic kilometer of water is already being withdrawn in 1995. So imagine the kind of water stress that over the time we would face. The light yellow are those areas where the withdrawal rate is around 40% to 20% to 40%, and the light blues are where we have 20% to 10% to 20%, and those dark blues are less than 10%. And again, Bhutan falls in. Fortunately, Bhutan falls in less than 10% of the withdrawal. Again, yes, we do not have data for to ascertain that we fall less than 10%, but yes, definitely we are good in terms of water withdrawal. We have not withdrawn most of our water resources for now. But in 2025, we see that lots of water is being withdrawn from the countries, and those countries, those areas where water withdrawal were only around 40, those few countries or places where water withdrawal were more than 40% of their total water quantity. Now we can see in 2025 that these dark oranges have actually spread it. One has actually reached in the southern African region. In yes, India is one of the country where water withdrawal is quite high because of a huge population, and again huge population depending on agriculture sector, which are again depending on the groundwater withdrawal. So yes, water withdrawal and freshwater stress is looking real critical, and it's a stress towards water supply. So By 2025, the statistics says that two-thirds of world's population estimated to be under water stress condition. So two-thirds of the total population is going to be under world under stress. So look at even places, few places in Bhutan, let's say in Lobesa, we're still facing water stress. So just imagine other countries where they do not have good vegetation system, where they do not have natural rivers, natural streams, lakes flowing in their surface. What would be the condition of those places? So these are kind of serious issues related to water supply. The main thing that we need to know from the issues related to water supply is that we do not have much to give to the population from the actual water resources side, because that's only 0.01 that's being available for our consumption. Again, in groundwater, we have got 30% from the 2.5% freshwater resources. But again, at this withdrawal rate, the supply is very less, and it's a big issue. So this is the issue related to supply